Good morning, good afternoon, everyone. Welcome back to the second session of today. And I'm very happy to announce three speakers here with me on stage today who will be talking about the CAP.js community. We have with us Max Grünfelder, Oliver Klemenz, and Richard Lindner, and they will talk to you about the CAP.js community, of course, but also the architectural components that allow you to build real-time, multi-tenant, scalable business applications. So to not waste any more of their time, we're looking forward to your talk. The stage is yours.
Thanks, everybody, for joining the session. Yes, thanks everybody for joining the session about building scalable, responsive business applications with modules or plugins for the CAP.js community. We all heard in the keynote from Daniel Hutzl the term AFC. Maybe some of you wondered what AFC is. It actually stands for Advanced Financial Closing. It's a BTP SaaS application we develop. We are three developers and architects from AFC within SAP. And our application is built on CAP Node.js. I think we already started with CAP 3. So we gained a lot of experience already on how to build applications, how to build applications at scale, how to operate applications, and also how we do load balancing and a lot of other things that become relevant after you build the Hello World application, because I think we all already know how to build a Hello World Node.js application. It became really easy with the CAP tooling, but after some days or years, the application grows, becomes more mature, and we now have more than 3,000 users, more than 300 tenants, and then a lot of things like scalability and availability become more relevant. So what we want to show you is what we learned in those 3 years where we developed and operate the application, what best practices we can share with you. And with the introduction of CAP.js plugins, we want also to share what we externalize and what we can offer in the CAP.js community to help you build application much faster, much easier, and really take away a lot of pitfalls. So what you see here is we have also 90 feature toggles. Richard will talk about it later, and I think that's really important when an application grows to have feature toggles in place where you can switch certain things of the application from A to B, roll out features gracefully to some customers to test it, but also to have fallbacks. If you do re-implementation, if you refactor something, but you want to keep the old implementation in place and want to have easy switches to always go back if something goes wrong, and that happens, unfortunately, all the time. And we also introduced WebSockets, which Oliver did, is to really communicate to the users on the UI in a really easy way to have a responsive application that feels much more modern. And we want to do that with only a few lines of code, not writing a lot of technical boiler code. And I want to show that in a quick demo already, how all that things come together, which we built. And later on, Oliver will talk about the blueprint architecture, showing all the components we have. Yes, so that's the launchpad of our Advanced Financial Closing. And I think a lot of the components that we will talk about, you won't see them on the UI because it's hidden for users. It should be hidden for users. It should only really enhance the user experience. So the small thing I want to show here is WebSockets. And the asynchronous processing behind we won't see, because if we click that schedule button here, a lot of actual components in the background are touched. We're talking to S4 systems, we're using a cloud connector, we're using destination service. And all of that is done asynchronously. What we see here is that the UI is instantly free again. And what we see here now is that we got a WebSocket back and see that actually something happened in the background and the user doesn't need to refresh the UI by themselves. They see something like it is on github.com, that something changed, and then you get here the notification. If I do it again, here that small bubble that something changed, and then you can click the refresh button and then see, okay, something is going on, new data is available. And how and what components we use and how all that fits together in the blueprint architecture will now show us Olli.
Okay. Can you hear me? Yes. So, yes, thanks, Max, for setting the scene. As you said, we work a long time now for advanced financial closing, almost 5 years, and we gained a lot of best practices and experience. And yeah, we thought it may be a good idea to externalize those best practices into modules that we first made internal, SAP internal available, but then also thought, yeah, it may be a good idea to make this open source so that everybody can benefit from that, from our way how we build our application. And as said, the goal was to really have a scalable and reliable solution. So, and that's why we started the CAP.js community. You heard it in the keynote that there is a new GitHub organization, CAP.js community, where such projects are initiated. I switch shortly. Can show to GitHub. So I just want to show on github.com how this looks like. So this CAP.js community is the pendant to the CAP.js organization that you all may know, and then now there's also the CAP.js community that we initiated, but in contrast to the CAP.js, which is mainly let's say operated and developed by the core CAP team, the CAP.js community is a little bit more open. So currently it's by non-CAP team SAP teams, but yeah, there are also plans to open this up so that other non-SAP projects can join here as well. So currently we have this list, and to explain a little bit more how they belong together, I want to present this little architecture slide here. A moment. Okay. So basically, we have started with a normal CAP architecture. So we have UI5 for elements, we have the app router, we have a CAP backend, and we have HANA as a database. So that's basic architecture. And what we now did is that we enhanced this architecture with our modules. And one of the key decisions we made was that we split up our CAP server into 2 instances. One is the CAP backend, and the other one is the CAP worker. The CAP backend basically has the main focus of responding to the UI requests, so UI processing. Idea is that it is very short-living request, and that basically it's very fast and reliable, so that you don't block, for example, the event queue, or event loop, what can happen very fast in a Node.js environment. And on the other hand, we have the CAP worker that's basically for the backend processing. It starts. So one of the first modules that we introduced into this architecture very early was, for example, the OData adapter that is that exposes an OData version 2 protocol based on the OData version 4 protocol of CAP Node.js, because there is no built-in support for that. Another module that was added early was the MTX tool that helps you to orchestrate and to manage your multi-tenant SaaS application. That's also a very nice tool. So these are a little bit longer around and available, but now also made open source as part of the CAP.js community. And then now with the concept of CDS plugins, it was now very easily able to add more modules, and that's what we did. So I want to introduce now 3 additional modules, and one of it is the event queue. And the event queue now helps to process more extensive business logic in the background asynchronously, like Max has shown it. So instead of getting the UI request and then immediately doing all the processing, heavy load processing in the normal CAP backend, blocking the thread. This is not what we want. So what we did is basically when the UI request is coming in, we just store an event in the event queue, and then we respond to UI request. So it's free again. The UI is responsive again, and the user can continue. And in the background, the CAP worker now starts to work on this new event in the event queue. The work distribution is done via Redis, so the CAP worker is informed that there is a new event to be processed. And as the CAP worker also is multi-instance, an instance can now has free resources to process this event, can pick up this event and process it. And the nice thing about that is that the events are not only one step, but you have a real process chain, that you have events and the event produces additional events, and then you process a whole chain of business logic. And every time you get a load balancing, you cannot overload the instance. You even out the peaks of CPU and memory, and that's really nice features. We also have periodic events, and all this is done basically to be resilient, to do not lose any operation, and to be reliable in addition. And also the event queue supports the CDS outbox approach, so you can put this as a drop-in replacement for the standard CDS outbox, and it will handle this as well. Then another module I like to introduce is the feature toggles. So this helps to set feature toggles during runtime. I think there are some feature toggle solutions around there, but this specifically helps you to change the feature toggles at runtime for every instance that is connected, also using the Redis technology. And by this, we can somehow control our application during runtime. For example, if there's too much load, we can, for example, reduce the parallelism of the event queue, or change other parameters, for example, phase in some features or phase out some features. And now the missing gap, and this is the last module I want to introduce, is the WebSocket module. So we have seen on that we now are able to process events via the event queue in the CAP worker, but this is of course asynchronous to the UI processing. So the user would not be notified if the event processing finished, and of course refreshing the UI all the time is also not nice. And therefore we thought, okay, the missing gap would be that the UI is also notified when a certain step in the event queue was finished, and this is where we use the WebSocket technology. And we have built a plugin, a CDS plugin, to make the usage of the WebSocket technology very easy, handling all the nitty-gritty details you have to implement, and will also take care of publishing or informing the WebSocket clients that are connected to the backend, and then the event worker works on the CAP worker. So basically, the connection needs to be made also via Redis, that the WebSocket events are distributed across Redis to the CAP backend and then to the WebSocket clients. Okay, so that's basically an overview what we currently have in the CAP.js community. Everybody can use that. We also want to invest maybe in future into different topics. So we have a look at sub-build process automation and maybe AI and LLM, but this is more to come maybe in future. Maybe we can show something next year. Okay, that would be my part, and hand over to Richard, which talks a little bit more about event feature toggles.
All right, thank you. Let's see how this works. Oh, does this work? Okay, but it's still. So yes, I wanted to talk a little bit about the feature toggles. So you will have the chance to listen to an event queue session, a dedicated event queue session, and a dedicated WebSocket session right after this talk. But for the feature toggles, I gave a session last year, so you will not have a chance to hear this one again. But if you are curious about it, I shared the website here and the documentation that I write, and I will give a very, 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 very quick update about the things that work now that didn't work before. Yes. And for this, we will go here. So this is the feature toggle library repo, and in within this repo, I have an example server, which I dumped down now a lot for this little demo. And it is in fact so small because CAP does most of the things automatically that it does not need more than these 10 lines of code. So I just have one service, which is a check service, which implements one function, which is the priority function. And the implementation is right here. And what this does is it checks if the modeling has a marked annotation. And the reason I do this is because while this modeling of the service is very simple, I also have a feature toggle here, a CAP feature toggle, which is on this purely modeling level, which gives this service that annotation. Okay, and then I don't have to do anything else because everything works automatically. I don't have to configure anything. Well, I have to turn on the feature toggles for CAP, so CAP does feature toggles as well. But apart from that, I just have a dependency to the feature toggle library, and then everything happens by itself. Let's demo this real quick. So it starts up very slowly, and then it gives you an initialization text, and you see that one feature toggle was enabled automatically. It's currently not connected to Regis, but it doesn't matter for this little demo. And we can use HTTP to check that this works. So this will give us the current state of the feature toggles, and we can see, okay, I found one feature toggle for this service, and it's currently off because it's the default fallback value. And then we can use this to turn it on. So with this syntax, I won't go into details too much because it'll take too long. But this will turn it on for all users. And just to show off a little bit, I will turn it off again for the user Alice in Wonderland. And then if we check the state again, we will see, okay, the root value is now true. So it'll be on for generic users, but it'll be off for Alice. And when we do the requests, we'll see for Bob, it's true. And for Alice, it's false. Wow, this was simple. Okay, thank you. That's all I wanted to show.
So thank you so much for the session. Actually, on top of the hour, very well done. Unfortunately, we don't have time for questions because, as I said in the beginning, we have to be very strict on the agenda. But if you do meet them on the floors, feel free to approach them at any time.